And one. Good morning, good afternoon, or good evening, depending on where you're tuning in from today. We want to thank you for joining this TechStrong learning experience. We're joined with Harness today. A couple of quick housekeeping notes. The session is going to be recorded. It will be available afterward on demand. We're also going to send you a link to the recording once we conclude. We do have some handouts in the resource section on the left side of your screen. Go ahead and click those, get those downloaded, and make sure you check those out throughout the presentation. We also want you to engage with us. We've got a chat section. It's on the right side of your screen. Tell us your comments, your thoughts, your understanding on the matter. We do want to engage with you. We want to hear from you. So fill us in with where you're at. Tell us where you're tuning in from and why you joined today. We've also got the Q&A, which is right near the chat section on the right side of your screen. Any questions that you've got, make sure that they go into the Q&A section. Ask as many as you want throughout the program. We'll make sure that we get to as many as we can. And any that we don't get to, we'll send those over to Martin, and he can answer those later. And he'll get back to you. Let's go ahead and kick off today's topic. We've got why are you still using legacy CI tools? And we're joined with Martin Reynolds. He's the field CTO at Harness. Martin, thank you for joining us today. If you want to go ahead and take it away from here, I'm going to turn my camera off and hand it over to you.
Absolutely. And hello, welcome everybody. It's great to have you here. And I'm going to jump in and just share my screen here. And hopefully we've all got some slides in front of us now. So I'm going to talk about why are you still using legacy CI tools, which sounds weird because I'm not just going to be talking about CI. It's actually why are we using those legacy CI tools for all sorts of things that maybe there is a better way to do it. So I'm going to start today and just kind of talk about, not just our point of view, but just a point of view of where software delivery and everything is today, and then kind of really dig into some of the challenges of the tools that we use and maybe how we can do it better. So, right now, somewhere around 30 million software developers, across the planet, building software, whether that's for internal use or external for, customer facing, that is a huge number of people who are engaged in building software, in innovating and solving real problems. And that actually equates to a huge amount of investment by the companies that you and I work for. That equates to around $3 trillion worldwide. It's just an average salary calculation, but you get the idea of the investment that is made inside software engineering. However, more than 40% of time is spent on developer toil. And that is something we're really going to dig into here. And when I talk about toil, what I'm really talking about is, things that aren't, solving problems, writing software, solving bugs, maybe fixing technical debt. It's really those things that as engineers we're doing that aren't actually the innovation and the problem solving or the new features that we want to get in front of customers. Now, one of the side effects of that is that actually around 43% of developers say that they're not satisfied in their role because they're not doing the thing that they love because they're spending all this time doing other things, and that's something that we as an industry overall need to solve. And layering a bit more into this and a bit more pressure and a bit more problem is, the fact that, organizations report that of their production workloads, their software that's out in the wild, 60% of them have known vulnerabilities in them. That doesn't necessarily mean that they've been exploited, but they know that they're there and they know that there's something that they need to remediate. And this next one you might think is a little weird as to why I'm including this, but I think it's all joined up. And that is, that actually, because of the way we provision environments for development, for QA, for testing, for deployment, the cloud vendors, the hyperscalers, AWS, Microsoft, Google, they're saying that from the utilization they see on their machines, that they're actually, getting around 28% of that spend is wasted spend. That's money that the companies that you and I work for spend on cloud waste that they don't need to. In fact, our own CFO here at Harness was saying that quite often after things like salaries, cloud spend is often the second or third biggest item on their list of expenditures for engineering and software. So it really has a big impact, and maybe that's something we can do better too. So digging in a little deeper, I'm kind of going to go through into, I'm going to go through this slide. Some of you may have seen me do this slide before, but this is actually, I'm going to talk about it very specifically around what we do often in a CI tool that isn't CI. Okay, so, I'm mentioning this because developer onboarding and getting started is kind of part of the overall SDLC. And developer onboarding, I would cover in two things. That's I'm a new developer, or actually I'm a developer that's moving from, project A, and I'm moving to this new project over here. And we have a lot of institutional knowledge. And a lot of, we have our IDEs that we work in and the code repositories. Now, that institutional knowledge is quite important here, especially when we're talking about the way that we use things like Jenkins and maybe Travis, and a whole bunch of other tools that are CI build tools. Often the way that they work and the way that they're configured is part of that institutional tribal knowledge, maybe within a team. Now, eventually you write some code and you build and you commit that, you've got your PR, and you want to get that built and tested and out the door. So we have those kind of build things, often manually scripted inside a build engine like Jenkins or others, and that can have slow build times. And we all love things like GroovyScript. That means that there is a maintenance overhead for those. And quite often there's security testing that we need to do, and that actually causes its own challenges too. So normally we're scripting that information, those runs. So we're saying, hey, let's run our SonarQube check, let's run our check marks, or our Wiz, or our Black Duck, or whatever it is, the security scans that you want to run as an organization as part of your build and your overall governance. And then as an engineer, great, it's run, tick box. But what I don't know, maybe not even at this point, and maybe not till later, is it's great that it's been run and I can tick that box, but actually what's actually the outcome? Has that impacted? Have I done anything that makes that security situation worse? And when do I get to see that? And which tool do I go to see it? So that's all part of it too. And then there's the kind of, especially now, that kind of resilience testing. Is my service going to stay up? Has it passed all those smoke tests? Have I had an impact on my service level indicators or my SLOs, my objectives? Again, probably separate tools and probably going to another place to be able to see that. And as you can see, as we're going through this, you can see the amount of time and cost and impact on people and dissatisfaction that these are having across the board. And then you actually get to that release process and you have to manage the infrastructure and maybe run some infrastructure as code or update it or check for drift and all of those things. And there's probably a change process that's happening. And quite often, you've got a kind of manual approval process or, and often not integrated with your CI, or if it is, it's probably scripted. So that, again, that makes it difficult to do. And maybe you've got some DB migrations that need to happen around the same time. And that deployment ultimately happens. And often, especially in CI tools, those deployments are heavily scripted that require a lot of maintenance, or they have manual steps and they're difficult to troubleshoot. And then you kind of have, once it's deployed, and often we are using CI tools to do this deployment, you have to do that verification and really understand what's going on, maybe looking at those, some of those great APM tools that you've got implemented and understanding. And then, if it's all going wrong, how easy is it to roll back? I have worked in organizations where before we modernized our DevOps processes, our weekends would take a release, take a weekend. We'd start on Friday night. There'd be a bunch of deployment that happened overnight into Saturday. And then there'd be a bunch of testing on the Saturday. And then we had a cutoff point on kind of about 11 o'clock on the Sunday, because it would take us from 11 o'clock till like 10 p.m. or whatever on the Sunday, 11 a.m. to 10 p.m. if we wanted to roll back. And it shouldn't be that hard. Yet I know because I talk to people all the time who still face these kind of problems in some of their environments, and because of the way it's scripted, and often those rollbacks are manual and take a lot of time to do. And then overall that in kind of this ever-changing and increasingly regulatory environments, understanding what's happened in that pipeline, seeing what happened where, did all the right things happen, is often very manual. It takes a lot of effort. And then, are you complying? Do you have good secrets management? Do you have all the right auditing in place for maybe the environment that you're running in, or the regulations that you need to be compliant with? And that can be, even if that's just for, ISO 27001, or, maybe you have, different regulations, maybe you're complying to DORA or NIS2, or, or maybe you work in healthcare and you have specific requirements there, or finance, in these regulated environments. So all of that, needs to be somehow catered for and either pulled out from those scripted environments or managed manually along the way. And how do you know how you're doing? You need to measure all those things. And then finally, again, those cloud resources across this whole journey, as we've gone from like build, test, release, verify, there's probably maybe been 3-4 different environments that have been spun up or are running all the time, and maybe not running all the time, but not used all the time, and are we optimally doing that across the piece? So what does that really mean in terms of, the challenges that we're facing? And I kind of highlighted them at a high level as I went through there, but actually, this really kind of digs into those challenges a little more. So, we talk about disjointed tools, and you saw across there's a whole bunch of tools that are in that space. There's absolutely tons of them. And, we did a survey recently that actually highlighted that they're, on average, most software developers are actually using need to know 14 different tools. 14. That's an insane amount. And given that that's the average, that means that there are ups and, some people are learning more and need to know more, and some less. But that is a huge number of tools to do. And that means that engineers are getting out of that kind of development flow to context switch to see the right information at the right time. Then we kind of have, those slow builds and testing cycles, script creation and maintenance across that whole piece, manual processes to resolve build failure. So if a build does fail, you have those big long logs to go through to work out where it's failed and why it's failed and what you might need to do to fix it. And then that kind of change process is often manual or ticket driven, to get the approvals in place, rather than having so you've got all these stage gates that you need to get through, and then the kind of whole deployment process and rollback can actually be quite labor intensive. Even the verification is labor intensive because you need physical people on the ground to be able to do that. And then that kind of inability to be able to govern that without sacrificing velocity. You want to be able to have all those stage gates and everything in place, but you don't want to actually slow teams down by having them, and it's difficult often to scale, and I've heard this described by one of my colleagues, where he's saying, he often talks to organizations, and what they have is they have, maybe 3,000 services, and he equates it to the way they, 3,000 planes. And the way they land those 3,000 planes is they have 3,000 runways, which is, not an efficient way to run. And, no airport would survive if they did that. Plus, half of every state or country would be covered with airport runways. Excuse me. So it's difficult to scale those configurations, and it's not the kind of thing that we're driving for as we move more into those kind of golden pathways to production. And often security is less integrated and more kind of bolted on, so those are often the challenges that you see when you're using those kind of scripted solutions, and some of those legacy CI solutions that, were great at the time because they're what was available, but now they're actually holding us back. And some of the consequences that come out of that, well, you know what, you're going to get slower innovation. you're actually going to get slower release and longer cycle time. So, you're not getting those features and fixes out to your end users or customers as quickly as you want. That means that, your GTM time for new products and services is going to be slower because it takes so much more effort to get them there in the first place. Excessive time wasted waiting for builds, or, which is essentially that kind of high developer toil, right? And inefficiency, which ultimately is increased costs, right? We talked about that 30 trillion kind of global investment, but wouldn't it be better if more of that 30 trillion investment was actually spent delivering those new features and go-to-market products that actually, increase the revenue of the companies that we work for and improve the services that we offer? And then there is the kind of, avoidable downtime and excessive mean time to recovery from having those kind of manual processes and steps in place, which again results in bigger costs versus, automating and having automated steps to do that. And then, finally, you kind of have that increased deployment risk because you tend to be able to, because deployment processes are painful and heavily scripted, you tend to bunch up more changes into those releases because they're happening less frequently, and you get that kind of increased deployment risk. So, I feel like here I've set kind of a lot of negatives and a lot of challenges that we face, and maybe it's time to talk about how we can do some of this better. And I do have a slide for that, but before we get into that, what I'd really like to do is show you what better can look like, and then I'll talk through some of those benefits and some of those outcomes that you get by going for that better future. And I'm going to do that by looking at some of the things we do in Harness to solve those problems. Before I kind of drop back and hopefully I will answer questions towards the end, but please drop them in as we're going along, because I would love to hear, the questions, and I will try my best to answer them before the end. So what we have here is, this is Harness. Harness is like a modular platform. Some of the principles I'm going to talk about here are global principles. I'm just showing you in obviously in the tool I know, and the tool I think does it best. But some of these principles apply everywhere. So what we have here is we're in Harness. Harness is let me just pop this out. Harness is a modular platform. We do many things across the software development lifecycle, but really what I'm going to focus on here is how you can kind of, go from a kind of scripted solution to something that is a much more easily maintained solution that can build. So what we have here is a pipeline that we use internally and often for demonstrating. And what this pipeline is a full path to production from build all the way through to deployment. That is a templated pipeline, right? So this is, if you think of that kind of platform engineering type approach, here is a golden path to production for I can't remember which language this is. Let's say a Java, containerized Java API to production. This is the path to production. If we build a new service, it will spin up this pipeline again and again and again, and reuse it over and over again, essentially. And if I want to update that templated instance and push it to all the services that are using it, I can do that with using versioning and everything else. So let's talk about some of the steps that make up that journey to production. I think this is set up as a fairly common path to production. So you've got your build and test. Then here what we're doing is we're actually going to spin up some ephemeral dev infrastructure that we're going to push in. We're going to deploy to that dev environment and run some testing. Then we're going to hand it over to QA and publish that QA environment. Then there's actually an approval that goes in before we publish to production, and then it will deploy out to production. And if you have it, then even once it's deployed, you can then enable your feature flags to turn on your features. So what does this actually look like? Now, the first thing I would say is, we have this visual editor that we use to do that. I will say that we are a developer first environment, We also provide all this information is available in YAML. You can edit it in YAML. It's stored in the GitHub repo alongside your code, so you can still have that developer first experience. However, I'm going to use the visual representation, which we actually find people, even people who say that they want to do it in code and YAML, often end up using this visual representation because it's actually a much easier way to do it in terms of speed and skill set and everything else. Here what we have is we have a kind of our build pipeline, and we would consider CI everything up to the point where you push that artifact up into wherever you're storing your artifact, whether that's JFrog or Docker or wherever. Right. So here we have a bunch of stuff. So we're checking our Git repository with Git leaps. We're doing some build and testing here, which I will come back to in terms of what's going on here with this kind of build and test intelligence. We're doing our security scanning. So here, and we've also got our SAS scanners with Wiz and SemGrep, and we've probably got more than most organizations would show here. But what we're really trying to show is that they're all there. Now, one of the things I would say is that, this is a kind of a common pipeline. It pushes that in. Then we're doing some SBOM generation, and we're just doing some final container scanning at the end. And this is our pipeline. And what we've got here is like really a common way of doing it. It has all the steps in that we should do along the way. But what happens, what does it look like if I wanted to add a new step in? So, if I wanted to add a new step in here, instead of creating a script to do whatever it is that we want to do here, I've got a selection of all the kind of build things that I want to do that are kind of out the box, that we might want to do. So maybe I want to add a sysdig scan in here, and I can just come in, put that configuration in, and apply the changes, and I'm done. There's no scripting involved in that. It's just a straight integration that is there and kind of out the box. I'm actually going to discard those changes really quickly. Then I'm going to go back and what happens if I'm an engineer and I want to remove the Wiz scan right here, because what? My build keeps failing on the Wiz scan and it's really annoying me. So what I'm going to do is I'm going to come in here and I'm going to edit my Wiz scan. I'm going to just remove it from my pipeline. I don't want it anymore. So because it's blocking me, and I spoke to my friend in security, he says that's okay, so I'm going to do that. So I'm going to take out this Wiz scan and I'm going to try and save it. Now, what this is going to do, as you can see here, maybe normally what I would do is I would put this in a branch and do a PR, but I just want to show this as an example really quickly. So I'm just going to, kind of cheat and say, I just want to commit to main. And I'm just going to do that. So what's this just checking and doing that save? What's actually going on here in the background is we have a bunch of policies that we build in, that you can build into the Harness platform, that allow you to set what's allowed and what's not allowed within your organization, right? So instead of having lots of gates that say, please tick the box that you've run this security scan. Please tick the box that you've done this. Please approve that you've completed this testing. Please approve that you've completed this testing. Actually, what we use Open Policy Agent under the covers. It's across our entire platform. What it allows you to do is actually set a policy that says, hey, these are the policies that we have that you must do these steps. For example, you can see here, there must be an approval required for deployments to production. There's some commands that you can't do in run steps for if you added some scripts. There's org level pipeline policies across here. And specifically here, it's saying, hey, you can't save this build. And the reason you can't save this is because there is a policy that you must run a Wiz scan as part of your CI stage. And that's set at an organizational level. So what we're really doing here is saying, hey, engineers, it's just easier for you to do the right thing here. And if you're doing all the right things, it's an easy route, and it's hard to do the wrong thing. And we're deliberately making it hard to do the wrong things because that's the policies that we have as an organization and the standards that we're setting, and those policies, there's quite a lot of policies out the box, but obviously you set your policies based on what works for your organization and what compliance levels you want to set for your organization. So, and that's really the goal, is to kind of remove some of those, those gates that you have across the way, because you have it set as a policy. So rather than go through all of these things, and there's just a couple I want to check out. So here you can see in the deployment that actually we're, as part of the change management, when we've deployed to dev, we're actually saying, hey, let's create the Jira ticket for change management and update that along the way. One of the really interesting things is that you can actually choose what fields go into that ticket. And you can really do that across the way. So here you can see the text that's going in. You can add fields into there that are the fields from your Jira or your ServiceNow, so that ticket actually makes sense. And we can update that ticket to make sure it has all the right information, so that by the time we get to this point, it knows that it's actually been deployed to dev, it's been deployed to QA, that all the right testing has happened in that ticket. And that everything's going on in the right way, so that by the time it gets to the overall approval, you can see, as I go through the stages here, it's adding more testing and everything else along the way. All of that testing information and everything else is updated. And you'll even see that I have auto stopping enabled in here along the way, to make sure that that infrastructure is only running while I'm running the tests, and to make sure that I'm it's being smart about that, and it's part of the pipeline. And again, all of these are come in, and you just update them with your config to make sure that they're doing the right things. And you're not having to maintain lots of scripts to do that, because all of these things, all of these integrations with hundreds of different products and partners are built in out of the box. So let's take a little look on the other side of what that looks like, when you're running. So let me just come back, and here I've chosen this pipeline deliberately. So it's the same pipeline you were just looking at, and you can see here it's successfully built. But one of the things I wanted to pull out here is, and this is really playing into, modern CI and modern practices, right? So when the pipeline executes, some of those steps explode into the things that are happening. So actually the build is checking out the code base, it's restoring a bunch of things from cache. And you said I said previously I was going to have a look at, what was happening with test intelligence and build intelligence over here. So what do those do, right? So here, what build intelligence is doing is it's actually looking at the previous build steps that ran last time this built, and the dependencies that we use and the versions of those dependencies. And actually, do you know what? If there's no need to run a step because the outcome would be the same because nothing's changed, or those dependencies are already cached, it brings those in, right? So here you can say that it's saying that actually it was able to restore 20% of that. That means that the time it took to do that was a lot less. And then, you can see overall it's saying it saved 7 minutes on this build as a result of those intelligence steps. So now I want to talk a little bit about the test intelligence. So, and this is one of my favorite things. All right, if I go over here to the tests, right, what you'll actually see is it's saying there is a total of 9,624 tests against this particular repository. And actually, it chose 1,502 tests to run. Now, why did it do that? Well, it did that because it looked at the changes it looked at the code that was changed. It looked at the areas of the system that were of the test suite, of the unit tests that were correlated with that code, and then only ran the tests that were associated to the code that was changed. So essentially what that means is, it's like that thing of saying, hey, I've changed my wing mirror on my car. Do I need to do a full, 200-point inspection, or do I just need to check that the things associated with the wing mirror are still working? Do I need to do the 10 tests associated to that, or do I need to do the 2,000 tests about testing my entire car? So that's the kind of difference, and that's where you get some of those benefits. And then, going back to the pipeline really quickly, you remember that we had a lot of security tests, right? And those security tests, Does that mean I need to go to Black Duck to see the results, and then I need to go to Snyk to see those results, and I need to look in Wiz, and I need to check my code compliance in SonarQube, and where and this is part of that developer experience where they're saying I need to go to 10 places, 15 places to see all of that. Why not just have that all in one place, right? So what we actually have here is we have the results from all of those tests, and we can filter those. We can see that actually what we've got here is we've got the total issues for the build that I've just done. There's 272, but actually 244 were already there, right? And actually based on our policy, there's one new critical, right? I've added one new critical, and I can actually look at that one critical I've added and see what it is. And you know what? It's going to tell me what it is, right? And it's saying, actually here, it's saying that there's it's using AI to look at the remediation. It's saying there's not, actually here it is saying the remediation. But if there wasn't a remediation, you could actually say, you could put a request in and say, currently there's a fix and available. Can I get a 7-day exclusion to still be able to deploy this, because I know that jQuery is going to have a new fix in 7 days, and I will be able to update it by then. So can I let this through because I've got that change? Security can come in and approve and reject that, and everything can continue. But what I have is that kind of much more focus. So even though I'm scanning with 6, 7 tools in this case, what I'm actually seeing is the one thing that I need to action, and I'm seeing it in context. All right. So again, kind of going back to that pipeline, let's kind of talk about the kind of we've done kind of that deploy, say the build stage. It's the same in the deployment, right? It executes all the different stages. It's working and populating those Jira tickets. You can see we're logging everything. You can see how it's doing the database updates here as part of that update process, all in line, all in place, ensuring that everything is updated along the way, all governed by that policy, those policy evaluations to make sure that everything is in place that we talked about. Now, I might be skipping ahead a little bit, but I'm also, I as you can tell, I could probably talk about this forever, but I'm trying to bring out the things that add real value, and the things and the benefits of working in kind of a much more modern, dedicated CD tool that takes away some of that scripting problems, allows you to use templates, removes those gates that you have, and instead gives you guardrails that, really allows that kind of innovation and freedom. Let's talk about when something goes wrong, all right? Because, in an ideal world, everything works perfectly and everything goes straight through, and you don't actually need to worry about when, everything, because it's going great, right? But eventually some things ultimately go wrong, right? And what we're going to look at here is what's gone wrong. So here you can see the deployments happen to the production environment. It's done the database updates, and it's doing a canary deployment. And in Harness, we have one of my favorite tools. I will say that I used to be, before I joined Harness, I was a customer, and this was actually one of my favorite tools, continuous verification. What is continuous verification doing? Well, instead of having your best developers, your best engineers, your DevOps staff, your cloud ops engineers sitting there post the deployment and saying, does everything look okay? What continuous verification does is it actually uses machine learning to understand what good looks like for your application, and then identify when there's anomalies, whether that's, hey, we always see these errors when we deploy, but actually we're seeing twice as many this time. That's a problem. What do we do here? Do we roll back? Do we roll forward? Is it okay? We can live with it. It gives you the information, and it takes you, straight to that solution, to what that problem is, right? So instead of you searching through all the logs to find out what's gone wrong, you can actually, jump straight in and view the details of what the violation was, why it was different. And it's telling you that actually, it doesn't normally get these Java runtime exceptions. That's an unusual event. It's not great. But then we've also got these new ones that are completely unknown. So we've had these before. They're not expected, but here these ones are completely unknown. We know where they are in the code. We know what the frequency is of happening, and as a result, that means that those nodes in my Kubernetes cluster are not coming up. That's not great, and that's built from a bunch of metrics and logs. So actually, let's go back and what it's decided to do on the back of that is, let me scroll that all the way across again for you. What it's done on the back of that is decided to actually roll that back and do a canary delete and go back to the previous version. And the reason it's done that is because it really wants to make sure that you're getting those right things. I've done a weird Zoom thing there. Thank you. It's rolled back and put it back to where it was and verified that it's rolled back correctly in the same way that it verified it rolled back forward. And that rollback was automatic. I would love to talk about many of the other things that are across here, including, how we use AI, but I do want to keep the flow going, in what does that really mean and what's the benefit of adopting a modern, CD platform versus using, your CI platform to do CD, to run your security testing and everything else. So I've shown you what I think some of those benefits are around templating, around version, around, guardrails instead of gates, making it easy for those engineers to do the right thing and hard to do the wrong thing, being able to manage those changes. So what are those benefits, right? Means you get a streamlined and reliable build and release process that is reusable across multiple services, whether that's the whole pipeline or parts of the pipeline that you can use consistently and repeatably across your pipelines. Having 2 runways instead of 200 or 2,000, and having that consistency. By integrating the tool sets that you use, and as you saw from this, what I've been showing you today, what you want, and one of the most common developer experience things that we would recommend, and we see our customers and and my peers in the industry advocating, is having that having a seamless SDLC toolchain doesn't mean that you have just one tool. What it means is that you have a tool set that is well integrated, that surfaces the information at the right place and in the right time, whichever tool is the source of that information or has generated it. That you reduce that level of scripting and therefore reduce the maintenance level, right? The less scripting there is, the less maintenance there is, allowing engineers and platform engineers too, and DevOps engineers to focus on higher value things, which might be adding new technology, reducing security vulnerabilities, expanding out your overall developer platform to be able to adopt new technologies. Again, you heard me talk about those reusable workflows. It just makes sense, and it's how you do things at scale. You have that frictionless process. In fact, we have some of our customers specifically I've met and they've come to speak to us, at an event, and they've come up to us and literally said, hey, I know we use Harness. I'm a developer. I know I have software that's, deployed every single day with your software, but I've never actually seen it. The reason they've never seen it is because of that frictionless continuous delivery. That process is refined, it's templated. It is a known route that is used again and again and again. So it very rarely has a problem. And when there is a problem, it's solved automatically using those tools to ensure that there is minimal information and friction in getting from artifact to production. It also means that you get much better collaboration across the teams, whether that's devs or ops and security, because security can help define those policies and guidelines to make sure that the scanning's happening in the right place, that new things don't leak out into production, and you're at least maintaining your state, if not reducing your security risk, because you're able to, you're not introducing new stuff, so you can actually work on reducing the stuff that's already there. That flexible, scalable governance is that thing about having policies that are enforced automatically rather than having gates all the way to check. And what are some of the outcomes of that? Well, guess what? If you can build and deploy reliably with minimal friction, you are going to accelerate your innovation velocity. And you're going to do that because you're spending less time on those toil items that I talked about in the first place, because you're having a much more reliable and repeatable process that allows you to, spend more time innovating and get those features out. Which is, faster time to market, which is better revenue or improved NPS. Or even if you're building for internal teams, it's about productivity, which is then about, more effectively, getting the job done. It improves that developer satisfaction and productivity. If they have one place to go where they can see all the information that they need, and it's in context and in flow, and they're not having to context switch, that means that they are going to be happier in their job, and they're going to spend more time building new stuff than chasing out deployments or problems post release. And that improved efficiency ultimately ends up reducing costs. Actually, because you have a repeatable, reliable process that does all the right testing along the way and ensures that testing is done, that means that actually what we tend to see is higher service availability, and we see a much lower change failure rate, right? Because you're catching those challenges early, and while the developer's still in flow, they get fixed rather than, bunched up many changes, because those small changes lower change failure rate. Higher change rates, but lower change failure rates. That's going to give you, improved customer satisfaction scores, which ultimately is going to kind of lead to increased revenue or increased customer satisfaction, higher engagement with your services. Fewer quality and security compliance issues, because everything is audited from code all the way through artifact to deployment. Where everything is, when it was scanned, who scanned it, who tested it, what the tests were, how many succeeded or failed, which environments it was deployed to, everything else, which is overall a decrease in risk for the business and a decrease in risk for the software that's out there and running. So I'm just going to stop sharing my screen briefly, and I'm going to have a little look at the Q&A, which there it is. I'm going to stop sharing my screen. I will have a little look in the chats. I have a bunch of people, but I currently don't have any questions in the Q&A section. So what I will do is I will call out, I will say thank you very much for attending today. I very much appreciate it. I will call out specifically the Developer Experience Summit that we have coming up this week. It's free to attend. It's online. If you register, you can watch those sessions later, but we have some great companies talking about what they're doing with their developer experience and how they're leveraging AI in that process, including people like Cisco, Capital One are there. They're talking about that metaverse and many, many more. So I would recommend you sign up to that, follow the link in the handouts, and do it. I do have one quick question that's popped up, which is, can I run Harness on-prem? The answer is yes, you can absolutely do that. Let me separate that into two different ways. So actually the way Harness runs is you can run a self-managed version, but also what a lot of our customers do is Harness actually access a control plane, which runs in the cloud, but we have a delegate architecture, which means that the actual thing that's running the builds and the deployments and everything else actually runs in your infrastructure. We just access the control plane across the top. So you're still kind of running everything in your infrastructure, just the control plane is running at the top. That gives you kind of that pipeline engine. So there's a mix of ways to do that, but absolutely we can do that. Okay. I think with that, I will say thank you very much for joining, everybody. I hope you got something from that. Jared.
Excellent. Thank you, Martin. Thank you for joining us, sharing your expertise and the platform, and letting us know about the developer experience coming up. Again, that is in the resource section on the left side of your screen. We've got some handouts in there for you as well if you haven't downloaded them already. Make sure to do that before we close out. But before we do close out, we also have a survey in the resource section. Your input is invaluable. It goes a long way. It helps Martin. It helps Harness. It helps me here at TechStrong. So be sure to fill that out. It's 4 questions. It's very quick. And once again, this program is recorded. You will receive an email in your inbox shortly after we close out. Once again, Martin, I want to thank you for taking the time to join us. It's been a pleasure having you. And I want to thank everyone for joining another one of our TechStrong learning experiences today. And we look forward to seeing you on our next one. Thank you, everyone. Have a great day.
Thank you. Bye.